Hi, myself Akshay Kurhekar, a blockchain developer and CEO and founder of Monorekha Tech Innovations. Now, in this video, we're gonna see the detailed roadmap of how to be a good software developer. So, why I'm emphasizing more on software developer, not blockchain developer, because ultimately blockchain is one specialization, we can say, or we can say that it's a one domain inside the software development. But what is more important, to be a good software developer, if you are a good software developer, you ultimately become a good blockchain developer as well. So let's try to get into the video, and I'll try to explain this. Just one keynote here. Whatever I gonna present, or what I gonna deliver the content in this video, it's completely based on my experience and learnings, right? It's not like that I assume this, like this will work and this not work. That's why I'm not sharing it. This worked for me, that's why I'm sharing it. It's up to you guys. Now you have to take it or not. Okay, just I'm sharing like what things worked for me. Perfect. Now let's just start sharing my screen so you'll get things in a better way. And one more key thing here, uh, whatever I'm gonna present, this is based on experience and the learnings from past few we can say few months, and from few years as well. I'm doing a lot of uh, connecting with different experts, understanding their thought process, uh, taking their feedback, suggestions, what's good, how should we move ahead in the tech. And yes, this channel is completely tech, so whenever I communicate with someone, I talk more with respect to the tech and academics angles only. So yeah, I will try to address those learnings as well in this video. Okay, perfect. So guys, if you are a computer science student, it could be from BCA, MCA, BTech, MTech, BE, any background, any technical background, right? So for you guys, it's, of course, you might heard this thing from multiple times. Fundamental is very, very important, and trust me, now literally trust me, now due to AI, even fundamental become too much important. Now, people now, we can say the employer is not asking for this someone who is good at creating website, or someone who is good at writing the APIs. Now they want someone who are very good with the fundamentals, right? Because AI can do lot more job, but they need a smart mind which who can command the AI in a better way and analysis the output given by the AI as well, in a tech term, not in term of like how it is looking, is it good or not. No, it will look good only. That is sorted there, and it's upgrading. So it's always a learning model. Or after now 2 years or 3 years down the line, it will become more robust and more perfect in doing their job. But what is more important, the basics. That's what they are lagging, most of the developers. So focus on basics. When I say basics, what things come into the basic is not just about the DSA and OOPS. Basics is all about knowing the different components of computer, what are the different streams we have, what are the different domains we have in the software engineering, or computer engineering, or computer science, we must say. So start from somewhere, start the DSA, start with the array. First, understand what is DSA, what is advanced data structure, what is data structure, why data structure is important, where we gonna use it, what is the importance of it. Just understand that little bit theory, and then get started with the array. Try to solve the different problems of array. Understand what is array, why array is important in any software or any application or for programming language, where exactly it gonna use, right? What is linked list, right? What is a map, how is it gonna work, why it's important, right? Oops, object oriented programming language. Understand the OOP concepts like objects. What is objects? Very, very important. Everything is objects in the programming world, and object is the smallest, fundamental, we can say, uh, a data set or a structure which is going to move here and there in most of the time. So understand the objects, getting the clear picture of objects is very, very important nowadays. And then functional programming, functions, how functions works, loops, controls, how control works, abstraction, inheritance, and lots such concepts. Try to understand that. It's literally understand. See, you might feel like this is again same boring stuff, but no, I'm trying to emphasize that please spend your time on this. Now the good part is if you are in first year or second year, or maybe in third year, you have a lot of time, right? You have a time, utilize your time, get clear. If you have not started yet, no problem. Start with the array, start with the linked list, do some programming, create a notes, maintain notes. Very important. Maintain notes parallelly. Whenever you are learning anything, maintain notes. Do the consistent practice of all those things. And at the same time, try to get little understanding of computer hardware as well, like how computer hardware works, what are the different components is there. The basics of IoT is also try to explore the different domain, how IoT works, sensors. Like we have a mouse. Mouse is also one of the IoT component, right? Keyboard is IoT component. So this thing, just I'm trying to give you the overall idea. When we say computer engineer is not just about doing the programming or just simply understanding how that building the software or website. No, it's not like that. It has a huge scope and wider area. Computer is always a mix of hardware and software, right? So you must need to have the clear picture of like how hardware works, how it is bind with software, what is the dependency of software if we have not provided a proper hardware to that particular software. That's where now I'm at the same time I'll try to bind these same words with the current situation. Now uh, two things is coming in the tech world. One is AI, right? It's already there. And AI, the people now believing more into the hardware now. Hardware in the sense they are talking about GPU, like optimization in less hardware. How can you build a more robust AI models in less GPU consumption? How can you build the good AI models or train something, some methodology you can develop? So now see, so now hardware is coming into the picture. So you must have a detailed depth knowledge how the task get control inside hardware. What is GPU? What is CPU? Why it is important, where is gonna use, how it is going to use. This type of question you must need to ask yourself. Write down the questions. Asking question is very important. Write down your question and try to research on that particular question until and unless you get satisfied or your respective answer to that question. Keep digging into it. That is very important. And second thing is quantum is also coming. So where in that also people is more talking about, the expert is more talking about, more worried about the hardware. Quantum is more directly related with the quantum computer, which has the complex hardware structure, how their system is getting designed. The bit, we have a byte concept, right? Byte, bit, how it is data transfer is happening. At the same time, how your parallel programming is happening inside the quantum. It's quantum is more about doing same thing in a parallelly, in a exponential way. So that's a futuristic. But what I'm trying to force here, fundamental is very important. And at the same time, awareness of hardware is also very important to be to outstand yourself from the crowd. That's very important, right? Now, once you have the fundamentals, do the daily practice, maintain some I must say, create some tasks to yourself, get the big good understanding, and then you can switch later slowly to the computer systems. First, why I'm not directly suggesting to go things, because you need some confidence in the world to survive at the same time. So that's why first get into the hands. You'll find lot of resources online here and then free resources. So build your little understanding so you could be able to understand things at the application level, right? So when you did little programming, you have selected any particular programming language, and yeah, in phase one, after doing all those things, parallelly you have to choose one programming language as well. So you can choose anyone: C, C++, Java, JavaScript, Python. Anything is fine, but I would suggest it's good to start with JavaScript or C, C++. That would gonna give you little tougher way to do the programming. Python is little easy, so you may not understand most of the concepts in that detail, but yeah, it's good to have anything is fine. Now, when you have phase 1 is done. Then in second phase you can go a little deeper with respect to the computer systems, where you can go in detailed about OS, how operating system works, what is iOS, how it is different than Windows, what is Linux, what is Kali Linux, Ubuntu, all those different OS we have, operating system, why it is important, why there is different operating system, what is the purpose of it, in which industry which operating system is using. Understand that, right? Create a notes, build a notes around this will going to help you in a longer run. Memory management. In computer system there are multiple components. I have list out to very high level here. Memory management is very important, how that memory gets stored, how to optimize the memory, garbage collection, right? What are the different methodologies there to prevent the garbage collections, how the task performance happen, task scheduling is there, the concept. When we triggered one button in our laptop, let's say I'm doing here cursor, I'm moving cursor, how this cursor is moving, I can see this as application, but how it is going to my operating system, how operating system is behaving on my input, right? That is very important. Now I have multiple things running. My son, one recorder is also running there. My mic is also here to my same system. How this multiple operation is happening at the same time, how multi-threading is happening, how the scheduling of task is happen. So there is a interrupt, and if someone going to interrupt, there is a priority, which task is going to do first, the parallel execution, priority task. So these all things in your subject itself, it's the part of your I think BCA, MCA, or engineering, or IT domain. It's your subject things only, just you have to get those things properly, literally very important. And slowly you can go into the microprocessor and microcontroller. So microprocessor, I'm not saying that you have to be get a very expertise in there are micro programming language as well. So microcontrol for microcontroller and microprocessor, there are other programming language where you can type the, it's a very low level language, where simply with the single statements you will going to assign variables, shift the variables, increment variable, decrement variable, perform loops and all those things. We don't want that, but at least understand that why it is important. So you will going to understand the how computer architecture work, how the processing work, if any input we are giving, how it is handling, how complex it is, what how much time it will gonna take, right? That's what I'm trying to understand. So that's what I'm trying to emphasize more on, that get the detailed as possible. Because again, now this is the exactly correct time, even though if you are pass out, or you are in a early career of your phase. So do all those things if you have not done so far. This is going to help you a lot, right? Then computer networking. So understand about the computer networking, what is HTTP, TPS, what is TCP, what is IP, what is UDP, what is DNS, right? How it gonna work, what is WAN, like there is a LAN connection, right? So different connection is there, wired connection is there, there is a mesh network like local LAN, global LAN, the internet, how internet works, how the wiring of internet is get set up. We have a multiple satellites, right? How telecommunication works, right? This is also part of networking itself. So there are huge, networking is a huge domain. That's where the blockchain part will also come into the networking part as well. So I have a huge interest into the networking from my long graduation days. So that's how I land up into the blockchain world. I'll tell you that. But what I'm trying to say, go little deeper and explore all these things as well. So no need to explore all, but good to explore all, but you should have a basic understanding. Then if you have the basic understanding of all those things, and one should have in any one of these, you should have a detailed understanding. This will help you a lot, okay? And then we can talk more about the, once you have done with this, then you can go in a application layer. Application is layer like how the databases works. In databases there could be a MySQL, right? You can explore MySQL, then MongoDB, PostgreSDB, right? Oh, MongoDB, PostgreSDB, something like that. All different type of databases you can explore over here, which is going to help you. Once you learn this, you'll understand how database works, complexity, the volume of data we need to handle, and why there is a structured query language and non-structured query language, right? What is the difference between it? What is a data normalization concept? How the object works here? That I told you in a very first slide, objects. Because here, when we talked about MongoDB or big data, those are object oriented. Like they are not in a structured format. Everything, whatever the data they will store as a one single object, and that object can go little big, too much big, or little so small as well. So they have a nested object concept. So in single object you can create multiple objects as well. So all these things we're going to address in this particular, your all these doubts will get cleared in the databases, right? And REST APIs, like how to, very first, what is APIs, right? You have to understand what is a API, where we gonna use API, why it is important, how to make a public APIs, private APIs, how to secure the APIs, how the data transmissions happens in the API, how to make sure that whatever the data you are transmitting with respect to your different methods, maybe the post or maybe the get, all those put, how you are securing that data, making sure that what ensures that your data transmission is in a secure manner, what is SSL certifications, HTTP versus HTTPS, right? All those things you need to understand. I'll just write it over here: SSL, HTTP versus HTTPS. All those things you need to understand. So you're gonna get much clarity how things will work. What is server? What is client? Client is like the front end most of the time, right? How front end works. Now there is technology is moving so fast. Server and client is getting merged in the single format as well. Now there is a backend-less concept. People is not building the independent backend because there are such platforms which is acting as a backend provider. Okay. So, like example of Supabase. Supabase is something which is a backend provider. You don't need to build your own Node.js or different backend from scratch. Just simply write a edge functions or some APIs on there, and you can use it directly in your front end, right? So these type of things are changing. To understand this now, see, people directly building the tools, but now the early developers they don't understand. If they directly jumping into the what we say Supabase and such type of platforms to use, they don't even understand what is backend inside that. This is just, they will feel like this is just a CRM tool which is just handling the databases and giving me the output on my website. But it's not like that. They have the backend running on their servers. They have edge functions. Those, they are giving you the some endpoints to use it in your front end, or they are using it directly programmatically as a, but under the hood it is a client and server, and they have a proper communication. So you must need to understand how the server works, how client works, what is a server data handling there, load balancing, how the load we're gonna handle. But that's a later stage. But at least you should have a understanding how front end is different than back end and how it is bind with each other. Okay. Then uh, user authentication is very important. When we say we created one user interface and then we have to do the login and sign up part. So simply it is not like just storing the database entry and comparing the value against that user's password and all those things. You have to maintain the session. You have to make sure that this user is the, let's say user one is, we have to make sure only user one should see their data, not other people cannot see their data. And at the same time, there thousands of users should able to use my same website at the same moment, right? So how you are going to handle the different session and all those things will come into the session management and user authentication. Very important, very important. Just go into this, go little deeper into this particular concept. This will going to help you for longer, and most of the attacks is going to happen on this particular layer itself. User authentication must be very strong, otherwise your software is going to screw very easily. Okay. Data flow, how the data is going to flow from your user authentication model to your front end, to your front end to your back end, and then to your database, or and all those things, how your flow is happening, what data is flowing, what is the speed of like how your data is flowing, how efficient it is handling, all those things. And error handling, exception handling, error handling is very, very important. If you won't handle exception, your backend get crash, your front end might get crashed easily. And if crash in this is, it won't start automatically. You need then manual interventions to bring the system up again, right? So make sure that you handled all those things properly, and learn more about this, how to handle, what is try catch, right? We have different approaches here: try catch, exception, returns, and then the conditional. There are logical exception, there are some programmatical exceptions, mathematical exceptions, and all those things we have to understand, and we have to return the correct error messages from the uh, when you are developing any software or tool. So it's good to learn all this concept. Don't worry, I'm gonna give you these slides as well. We'll put somewhere on the drive. Now, you once you have a basic fundamentals, application layer, now it's time to go little deeper into the any particular specialization. We can say like networking. You can go little deeper into the networking, then you can explore the more concept of, if you are lot into the networking, then you can concept the 5G concept, how 5G works. Then you can concept the explore the concept of blockchain, how blockchain networks work, the node topology, what is meaning of node, how node is connected with the another node. Networking is the where the encryption, decryption will come into the picture, because it's like firing the sending the data from one point to the another point, how it is getting stored, the data packet, how it is getting transferred. All those things will come into the picture. Then here only your security point of security angle also you can explore, cyber security stuff like DOS attacks and different things is here. How to secure your network, how to secure your infra, right? All these things will come into this particular point. Networking algorithm, very important. You can explore the different algos. Now there are n number of things. There are a lot of, you might have heard, NP problem, right? So knapsack problems. There are dynamic programming is specifically on algorithm. They have different good algorithm problem statements opens, where we are talked about geolocations, like how this geolocation works. Like there is a Discastras algorithms which is going to explore the nearest node and then find the distance between it. So this type of different algorithm is there, so you can do more research on it. And it's not just about research, it's more about implementation as well, where this is going to play a huge role in your AI and ML stuff, like how you are going to use the algorithms, what is the methodology you are following in your training your model, what kind of algorithms you are using. Algorithm is nothing but the methodology, the way of using or doing the operations, right? Databases, again, you can go little deeper into the databases. The database has their whole domain. There is a big data concept. Now there is a whole warehouse and different data centers we have. So those guys need a very good understanding of databases, how to manage the big data, how to do the operations on the big data, right? So itself is a big domain altogether. We can explore this particular part. OS, operating system. So there are so many people who are building. I was just looking into something where people are building the OS on the browser, right? Or cloud based operating systems, so browser based operating systems. So there are this type of things is also happening. So if you want to contribute in such thought process like cloud based operating system and all those things, then for this you need the understanding of like how operating system works. That's what I mentioned in the earlier side, right? What are the different components is there, how the compiler work, how the lexical analysis work, what are the different task scheduling happen there, how the memory optimization happen in the OS, how the interrupts will work. All those things will going to get cleared with respect to OS. And this is a huge, and it's not when we say OS, it's not about just Windows or Linux or Mac. There are OS for hardwares as well. We have a EV, electronic vehicles, and then different lot of machineries we have. Those are smart devices or smart machines. They have their own operating systems. Yeah. So they have their own operating system, and that operating system are so lightweighted, so it can fit in on the same little small hardware as well. So you need to understand like how can we program such things which is going to serve the purpose of like that's how the operating system evolved over the period of time. Previously we have a big hardware to do the same operation, but now we have a little more smaller hardware to perform more complex operation than the earlier one. Like how this drastic things happen, this happens in the combination of hardware and the restructuring of operating system, continuously doing different methodology, applying different methodology, and always trying to increase the efficiency and reducing the size of the hardware, and try to do more operations based on less energy consumptions and all those things, right? So GPU, CPU, all those things will come into the here. Compiler is more like this is with respect to the programming world, but compiler itself is a big, very big thing. Now we have different programming. Let's say for example we can say Solidity is there, right, for blockchain, or you can take an example of JavaScript, C++, Golang. Any programming language always need a compiler. They need a base to execute their program. So that what compiler it is going to convert your high level thing or human readable stuff into the low level, the machine readable stuff. So but how it is going to happen, why it is important, how the system is going to understand your thing, what complexities is involved in this particular architecture, right? All these things you can learn in the compiler, very important. And at the same time hardware, just I mentioned, like different microprocessors, microcontrollers, different hardware devices, the motherboard, and all those other different concepts you can learn into the hardware to get the better understanding. See, just I'm trying to give the broader view, but you can do the the concept, the point of this phase is go deeper. So you don't have to go deeper into the each and every one, but you have to make uh, aware of all those things and go deeper into specific. Let's say my expertise, I'm trying to go always little deeper into the networking side, right? How networking work, how 5G works, how blockchain works, right? So that's how to build the network altogether, how to build the decentralized network, how to build a distributed network, what is a distributed network means altogether, how this VM can be connected to the from one cloud provider to the another cloud provider, right? All these type of things we mostly do in the networking. I'm talking more again on the application layer, but networking is more like how it is going to transmit your data from one location to the another location, and then and with respect to different methodologies and approaches, right? So similarly you can choose any particular domain and go little deeper into it, very important. Okay, now this is just, let me quickly revise things. We talked more about the basics, fundamental should be clear, DSA, oops. We talked about computer operating systems, memory management, right? Task scheduling. You must be aware about this networking concept, computer networking. Then application layer, database, REST API, server, front end, back end, authentication model, data workflows, and then you have to go little deeper into the any particular thing. So see, if you go in deeper, so now I'll try to correlate this thing with how this is going to directly relate with the current fancy technologies. If you are good with respect to networking and then databases or compiler or maybe the algo, then you can directly land up into the blockchain world or maybe in AI/ML world, right? Data scientist, or maybe into the IoT stuff. If you are very interested with respect to the hardware, you can go into the microprocessor, microcontroller. There are a lot of people who are building their own hardware based OS or small machinery based OS as well. So that will also get come into the picture. So there are different types of OSs, right? So databases, you can contribute directly into the data warehouses concepts, how it works, how to manage big data, data scraping, data mining, data mining. Yeah, data mining is a big thing because we have a lot of data, but we need a selective proper information out of huge data. How to collect the small precise information from big amount of data, that is all about the databases. And that's all things will come into the databases things. Okay, so just go little deeper, pick one thing and start digging into it. That's important. Now this is something non-technical, but this is going to help you to increase your efficiency. So what are the tips here? I want to give some key important tips which worked very well for me in the journey of software engineer and the development, where it gonna help you lot to very first always try to keep notes, keep as much as possible, keep notes ready always, keep note of your anything whatever you are doing, just write it down. Okay, always you must have a pen and paper with you to keep the notes. Second thing is schedule your time properly. Okay, time management is very important. Do the small tasks. Okay, distribute your times into the tasks, and do the small task, most probably small task, and do some what we can say, don't work on the same thing for longer run. Try to work on two different things. Let's say if you are exploring the DSA, then solve some problems of DS array, solve some problems of linked list, solve some problem of map. Don't always try to go in the single direction. So this will give you the little more what we can say, relaxation to your brain, and different things will get triggered. So you will try to correlate things as well, like how it is different than this and how it is different than this. So correlation. So plan task properly. Just don't plan the single task. Plan a distributed tasks. In short, do the distributed tasks and try to correlate with each other like this. And some key important things is fix your time. Let's say again, this is in the time management. Fix time for the task and the consistency. Let's say for morning, let's say I say from 6 a.m. to 7 a.m. in the early morning, I gonna do the regular DSA. So you have to fix this. Anyhow, whatever happen, you must need to do invest your 1 hour to perform the DSA in the early morning from 6 a.m. to 7 a.m. and try to wake up early. Very important. This worked for me. I don't know, so many people of you might be a late night worker, but working morning is always good. This is very important. And fourth tip is always stay healthy. Yeah, focus on health. If you won't focus on health, you're gonna lose a lot of things. Okay, so focus on health, eat more fruits, drink more water. This is a basics thing, but so many people always underestimate these things. They won't drink good much water, and they lose a lot of their health, right? So drinking good amount of water, eating good fruits is going to keep you happy. And if you have a happy quotient, your health is happy, you emotionally you are happy, then your effectiveness of your work is already going to go high. So this is all about this video, guys. I hope you gonna implement a few things out of it and try to get how can you land up into the good job and do better into your software development journey. And soon we're gonna start all these things in a little deeper. But yes, meantime, just do little practice. There are a lot of open source available, and I'll also try to keep things in a description, which is a open source study material for your journey. Thank you so much. If you like this video, please don't forget to like, share, subscribe, and comment on this video. Thank you so much. Bye bye.